Hi, my name is Ethan, and my project is about examining knee x ray scans with AI. The goal of the project is to differentiate between normal knee scans and knee scans with osteopenia or osteoporosis. My inspiration for doing this project is because I personally had knee problems when I was 12, but I wasn't even able to get my first x ray until a year and a half later. The reality is doctors are limited, and having AI be developed in this direction would be greatly beneficial to the medical industry in the future and provide more accessible examinations to regular people. The the idea behind the models is I train a model on ResNet 152 to detect whether or not the X-ray has a normal knee or an abnormal knee, and the second model on DenseNet 121 will differentiate between whether it has osteopenia or osteoporosis. So both models are still trained with all three classes because first off it prevents training bias, and second off, if the second model is trained on all three classes, it allows us to catch the mistakes of the first model with no consequences. So we could show that right here. If we if we use this photo, which is of a normal knee, and we run it through our code, it should print our stage 1 model, which is our ResNet model, the labels file, which has all three classes, and our stage 1 classes prediction here. So here in stage 1, it predicts it to be normal, but with low confidence. So we would activate the stage 2 model just to make sure that it's correct. And here the stage 2 model also catches on that it is normal. So we will end with a 46% confidence that it's normal. And the two models here, it sacrifices the confidence, but it improves the actual accuracy of the model a lot, because prior to this, with only one model, the AI would be confidently incorrect. So if you give it a normal image, it'll just say osteopenia with a 90% confidence, which is not what we want. And that's the reason why we have this thought process. And if we do the same thing, but with a photo of osteopenia, here stage 1 should be able to flag this as abnormal, and it'll call for the stage 2, which will either tell us if it's osteopenia or osteoporosis. This is the photo. So here it labels it as osteopenia with a 63% confidence, so it's a little more confident on this one. And if we scroll up, okay, wait, it's not there. And finally, we could test it on osteoporosis. And now the reason why I used two models instead of one is also because two models, you could catch mistakes. So if either models are wrong, we could still find the more accurate conclusion, because there's two answers being put. So now it says here it's osteoporosis with a 62% confidence, which is correct. And here we have our overlay, which is scaled, and our overlay would overlay this on top of that, so it's convenient for us to just send this out. And that's my project. Thank you.